Now we get to some of the fun questions to me. Look, they're not fun. Math's not fun for most people. I agree, most of you don't want to be here and do this, but when I say fun, I mean, why in the heck does this matter? In the real world, would I ever use this? And finally in a calculus class, because I know you're not going to use 2x plus 3 equals 7 and solve it. I know you're not going to use rationalizing radicals, rationalizing numerators and denominators as you go and buy your groceries. But hopefully the majority of you are going into some sort of business or real world problem, and you will be doing real world problems, and calculus is one of, if not the most, applied mathematics in the real world. We're talking about businesses here. We're talking about revenue. Revenue is the money that you bring in. And I want you to realize when we start doing real world problems, we start dealing with real world numbers. And real world numbers are not nice. We're going to have nasty decimals, we're going to have nasty answers, and that's okay because we have our calculators. The concepts are going to be the exact same. The concepts are going to be the same. We want to know a rate of change. We want to know a slope. Well, that's a derivative. We can find derivatives. There's no difference. We're just going to have some nasty numbers and have to use our calculators. So we finally get some real world values here. One of my favorite places to go, a nice little happy hour, would be Buffalo Wild Wings. This is what this problem is. This is real world numbers. This is not a joke. So it says from 2008 to 2013, the revenue in millions of dollars for Buffalo Wild Wings can be modeled by R equals 22.766 t squared minus 309.59 t plus 1,452 for 8 less than or equal to t less than or equal to 13. I want to emphasize here, notice that t is the year past 2000. So we're not plugging in 2008 for the year 2008. We're merely just plugging in the number 8. So this model works from any of the years from 8 to 13, which represents 2008 to 2013. So it says where t represents the year with t equal 8 corresponding to 2008. At what rate, that says what, should be was, the revenue from Buffalo Wild Wings changing in 2011. So what rate was the revenue changing? They want to know a rate of change. Rate of change is a slope. Rate of change, let me write that, rate of change equals slope, and we now know the slope is the derivative. How do I know that? Because they want to know the rate of change at a single point in time. They want to know the rate of change at 2011. So that means we need to find the derivative and plug in, well, 2011, we would just plug in the number 11. So that's the goal of this. What we're going to do to solve this is we're going to find r prime, the derivative of r, and we're going to evaluate it at 2011, which would be t equals 11. That's our strategy for this problem. Rate of change at a single point is the derivative at a point. Okay, let's find our derivative then. If r is 22.766 t squared minus 309.59 t plus 1452, what's the derivative? Well, r prime would be, that 22.766 is just a constant multiple, so that stays the same, 22.766. The derivative of t squared is 2t to the first, or just 2t. Minus, we have the 309.59 times the derivative of t is just 1, plus the derivative of 1452, well, that's a constant. The derivative of a constant is just 0. So r prime here is, well, 2 times 22.766. Please, by all means, get out a calculator here. I'm getting 532 t. And then 309.59 times 1, I don't need a calculator for that. That's 309.59 plus 0, that just stays off. But again, what was the whole entire point of this problem? We needed to evaluate it at t equals 11. So let's do that. R prime of 11 would then equal 45.532 times 11 minus 309.59. Of course, we're going to need a calculator on this one. Let's see what you get. I'm getting 191.262. So that's r prime of 11. Okay, we need to take a step back and realize, what in the heck did we just figure out? Well, first of all, this is a rate of change of revenue. And if you think about this, what would this be? So if I did the slope, and it's the change in y over the change in x, in this case, that's the change in y, our y value is r, over the change in x, the input was time. Revenue is measured in dollars. Time, in this case, is measured in years. So a slope would be dollars per year. That's the rate of change that we're dealing with here. So when we see that 191.262, the units of that is dollars per year. But we need to be a little more specific than that, because our revenue is not just in dollars, it's in millions of dollars. So that's $191.262 million. So really this is $191,262,000 per year. So what did we just say? First of all, I want you to realize that this is a positive number. A positive number means an increase. What does this mean? It means their revenue should increase by $191,262,000 for that year. That's not saying what their revenue actually is. That is not saying what their revenue is. Maybe their revenue was $1 billion. The idea is the next year it would be $1 billion plus the 191,262. Again, this is not their revenue for that year. That is the increase in revenue. Because it's positive, it is an increase. So I want to summarize that. It says interpret your answer using full sentences. This is what I would say. From 2011 to 2012, that's the 1 year, the revenue for B-dubs, Buffalo Wild Wings, is expected to increase by $191,262,000. So over that year, it is expected to increase by 191. Now this is an estimation. We could say to be increased by approximately if you want. I'll just put APX for approximately. Okay. It is expected to increase by approximately. Again, I cannot emphasize enough. This is not their revenue. To find their revenue, we would actually plug 11 back into the equation. In fact, let's do that. Let's just to strongly emphasize this. Let's plug 11 into this revenue equation. So in my calculator, I'm doing 22.766 times 11 squared minus 309.59 times 11 plus the 1452. I'm getting a number of 801.196. So what does that mean? That means their total revenue for the year 2011 is about $801 million. So if their total revenue is $801 million, what we should be able to do is plug in 12 now to see what their revenue is for 2012. And the idea is the revenue for 2012 should be the revenue for 2011, that $801 million, plus $191 million, which is roughly about $1 billion. So that's what it is. This number is not the actual revenue. It's the change in revenue. Derivatives are not the actual revenue. It's the change in revenue. Very, very important for you to understand what that means. So be careful with your sentences. Make sure you write a full sentence for me on these problems. Let's look at example number 11 here. It says from 2001 through 2013, the sales per share S in dollars for Walmart, again, real world data here, we're not messing around, can be modeled by S equals 0.1655 t squared plus 6.129 t plus 42.04 for 1 less than or equal to t less than or equal to 13, where t represents the year, with t equal 1 to corresponding to 2001. At what rate was Walmart sales per share changing in 2010? Interpret your answer using full sentences. So they want to know a rate of change at one given year. A rate of change at one given year. A rate of change at a point. So that means we need to find the derivative of the sales function. The derivative of the sales function at that point. Well, the point they want would correspond to t equals 10. Not 2010. It'd be t equals 10 in this case. So let's do it. Our sales function. What's the derivative of the sales function? Well, that would be, constant multiple here would be 0.1655. The derivative of t squared, again, is 2t to the first power, or just 2t, plus the constant multiple, so we have 6.129. The derivative of t is just 1. And then the derivative of 42.04, that's a constant, so the derivative of that is 0. Please use your calculator on this one. Again, real world problems, real nasty numbers. That's what you should be thinking. So I'm getting 0.331t plus 6.129. So that's the rate of change of sales. And again, I wanted to look at this at t equals 10. So what do? Plug in 10 to the derivative. That would be 0.331 times 10 plus 6.129, which I'm getting, 9.439? What's my units here? What should I be thinking? Well, again, my slope here is going to be my change in y over my change in x, except in this problem it's not y's and x's. My input value, my x is t, and my output variable is my sales. Well, what are sales measured in? Sales are dollars per share, and my time is measured in years. So when I look at this, my 9.439 would be dollars per share per year. That's my units there. So what in the heck does this mean? Well, first of all, it's positive. Anytime it's a positive, it's an increase. Anytime it's negative, it's a decrease. So this is an increase. So what does this mean? This is not saying what your cost per share is. This is saying what the change in cost per share is. So the price per share of Walmart is expected to increase by approximately $9 and should we just say 44 cents per share. And now remember, this is per year, but we have to be specific, from 2010 to the next year, which would be 2011. Okay. I want to make sure you understand this. The price per share, or sales per share, should be expected to increase by approximately $9.44 per share. That does not mean the cost is $9.44. It might be $100 per share in 2010. If it were $100 per share in 2010, then it would be $109.44 per share in 2011. So again, this number is not the actual price per share. It is the change in the price per share. I hope that emphasis really helps you understand in what we just figured out. Please write your answers in complete sentences.